All right. So what time do we finish this? Well, it's a pleasure to be here again. How many people here have been at GIDS in the past? Oh, very good. Okay, well, this is my, it's a third or fourth time that GIDS has been going on. So I think I've been here every year now, and it's been a real great, exciting experience and adventure every time I come. So I'm glad I could come again. This time I'm going to talk a little bit about Java EE7 and what we're doing to make Java EE7 be suited for the cloud. The cloud is definitely here. There's the standard disclaimer that I have to tell you that anything I say could be a lie and you can't make me pay for it. So please don't sue me. But I'm telling you mostly that the cloud is here. For those of you who haven't already noticed, I think probably most of you know by now that the cloud is going to be a fairly major part of your future. And that's why you're paying attention. That's a good thing. But Java EE has to pay attention as well. In order for us to be cloud ready, we have to have proper standards. We have to have a software stack that allows us to develop applications that are portable within the cloud. And so let's start off by talking about what the cloud really is. These are the three primary terms and different levels of the cloud. People think about IaaS, or infrastructure as a service, as something that Amazon kind of started off with Amazon Web Services and the ability to have resources. Resources are computing resources or data resources, any kind of resource that you might want to access, but essentially you don't get any software for that. You get drivers to control the resources, but you don't really get any software that allows you to do things with it. It was up to you to write the software and to run it on that resource. The next layer up from that would be the platform as a service, or PaaS. How many people here were at Arun's talk previous to this one? Okay, a few of you. So Arun talked a little bit about how Glassfish, as an application server, is implementing a PaaS strategy in that there's this layer above Glassfish and around Glassfish that enables it to be elastic and provide the PaaS layer for people to deploy applications to a PaaS environment. And now, PaaS generally means that you get the software with it. You get all the infrastructure software. You get the stack that allows you to simply take an application, write it, and deploy it to that stack. And you have to, first of all, be aware of what software sits there already. So you are not writing some API that doesn't exist. And lastly, software as a service, or SaaS. Well, I should say that in the PaaS case, we see some examples of that as well. Google App Engine was one of the first ones that came out. Very much a proprietary stack that had a lot of proprietary APIs. Amazon Beanstalk came out later, and that's been evolving as well into its stack. So there's lots of different choices now about PaaS environments. But again, they're all fairly proprietary. And the software layer comes above the PaaS layer. That's saying, now I have an application that's been written for a stack, and now I'm going to let people use the application. So there's a number of customers that come in and have a need for that particular application. And this is where companies like Salesforce have made all their money, where they have an application that people want to buy and use, and they don't care about all the things underneath it. They don't care about the PaaS underneath the application or the resources. They just assume that that stack will support their needs and that it will also grow and shrink according to their requirements and all these kinds of cloud-like properties. So this gives us a good context for Java EE, right? Because Java EE says, well, what is Java EE first of all? Java EE is a software stack. It's a set of APIs that we all know and understand and can write our applications to and know that they will be portable. When we go to one Java EE provider, we can load our application up, deploy it, and it'll work. And then we go to another provider, and maybe there's a few changes we have to make that are provider specific. But overall, you can pretty much port your application without too much trouble. Okay, that's the reality today. Now in a cloud, the problem is that these are all proprietary APIs. if you go working on Google App Engine, then you're going to have to write to the Google App Engine APIs. If you want to take that application that you've written for GAE and say, now I want to run it on Amazon Beanstalk, that's going to be kind of challenging. You essentially have to rewrite your application to use the APIs that the other PaaS provider offers you. So Java EE has a real role to play. Java EE came and offered a standard set of APIs that gave us portability. And now we want to bring that up into the cloud, where Java EE is a cloud PaaS stack. And this will be, I think, fairly evolutionary rather than revolutionary. We are all used to writing Java EE, so now we're just going to write Java EE in the cloud. And there are companies like CloudBees, for example, that has already started using Java EE in the cloud. There are other companies as well that have realized the strength of Java EE and leveraged it inside of cloud and PaaS environments. So we've modified some of the things when it comes to the Java EE specifications. We have some role adjustment to make, and I'll go over the roles, some multi-tenancy issues that we need to deal with, and just an understanding that we are targeting Java EE at the PaaS level, because PaaS is what makes sense for a platform like Java EE. That's what it is. All right, so some of the things that we've done is we've added metadata. When you talk about cloud, you think about services. You know, I have a database service, or I have a messaging service, or I just have a Java service, a programming service, if you like. And so there has to be something built in or something to enable the configuration and provisioning of all these services. So that's what we've been looking at. Some of the other qualities of service may also need to be configured. So we can have certain elasticity or service level agreements, or SLAs, associated with our application that involve these configurations. And there may also be some sharing. If we have resources that are global, where all applications can access them, or some that are simply tenant specific, and they're only private to me. And so these things need to be configured accordingly. We also have some APIs that we've added in that are useful in general, but particularly useful in the cloud. JSON has become quite a popular, I guess, protocol more than anything for message and object exchange. How many people here have been using JSON in some form or another? Yeah, I see that. There you go. That's almost half of you have been using JSON, and yet JSON wasn't actually in the Java EE spec. And so, technology moves so quickly, and so from one release to another, we have to reassess what's current, what's popular, and what's interesting for Java developers. And so JSON is obviously popular and current and relevant to Java developers. So you guys are using it in probably a RESTful web services context, most of you. But there are also other uses for JSON. So that will be part of the Java EE7 spec. There's a caching API, which also makes sense in the cloud. Given that most of the cloud APIs are RESTful web services, then JSON obviously has a role to play. But once you get in the cloud, then you still also have these other issues of the scalability of your application. And the caching API is going to play a role in that. In addition, people, because they've been using JAX-RS, people have asked for a client API. So we're going to be adding something in that area. And there are WebSockets and all these other specifications that are being added to not only help Java EE development specifically, but or Java EE development in general, but the cloud development specifically. And then, of course, as I mentioned, the multi-tenancy. So these are some of the roles. Now, in Java EE traditional, we had some standard roles. We had, there's this application developer, and they would give it to an assembler, and then they would give it off to a deployer, and then ship it into a container, and everything just works. Well, in the cloud, it's a little more complicated. There are more people involved. The roles have to be expanded to accommodate the new situations and the reality of the various parties that are involved in cloud application development and deployment. So you'll see that there's, I'm not sure, is this microphone cutting out, or is it just me? Is it okay? Is it cutting out? Yeah. Or are you only getting every fourth word? It may make more sense that way. It's like, actually, I'm speaking in code. So only every fourth word makes sense. The 3 words don't matter in between. I don't know what the problem is. It's fine. You can hear it okay. The people in the front row can hear it okay. So you guys must just be hard of hearing. What about if maybe if I hold it, just put it up higher. I'll try this. I think it's actually the microphone myself. Now you'll all be running out of the room holding your ears. Try this. Can you hear me okay? Every fourth word? Okay. So you see that there's a lot more involved in a cloud application. And I'll go over some examples of using these roles. Okay? And we'll see a little more closely about. Is it working okay? Yeah. Sometimes I hear coming out of the mic, out of the speaker, and sometimes I don't. Maybe the speaker's cutting out. I don't know. So, whoa. Okay. So I talked about services, and in the cloud, services are everything. In fact, services are the only thing. What you get is a series of services that enable your application. Your application gets loaded in, and it might get run by a Java service or something like that, and then it would access resources in resource services. And some of the services that you will access will be the ones that you access even outside the cloud. Persistent services. You always need to store your data, no matter where you're running. And so in cloud, a persistent service is definitely going to be a must-have. Queuing services become relevant as well. As you have workflow and you have data moving in and out of different places, sometimes you want to exchange messages and have messaging services that allow you to do that. I don't know, it's just me. But sometimes I feel like I'm talking to myself. You guys can hear, right? Any words you miss, I'll recite them afterwards. You can come see me. You have mail. Sometimes you want notifications. Sometimes you want events to be delivered through mail, all these kinds of things, and caching, as I mentioned. So what we did in Java EE6 was we introduced annotation called the data source definition annotation. I don't think making it louder helps. I think you just need to make it work. Data source definition allowed a data source to be created through an annotation. That might be a better idea. These work? Can you hear me now? Let's put this away. Not do ourselves any more damage. A very easy way of creating a data source within your application. It wasn't always appropriate. Sometimes the data source was something that you wanted to put in an XML file, for example, because it had, passwords or things like this in it that were, don't belong in your application code. But for cases where you wanted to get up and running, where you wanted to do all of your development and testing, then a data source definition was really great. It meant that you didn't have to do all the extra configuration in the application server to create and configure a data source for your application. What we want to do in Java E7 is extend this to other types of services and resources. So for example, JMS has been traditionally kind of hard to configure. And so what we've done is added the same level of annotation scope for JMS connection factories and destinations and such. That will allow you to create them using annotations. Similarly for mail sessions, you can create all these things using annotations and connectors, particularly for connectors, because a connector is often something that you deploy with your application with a resource adapter, and now you can simply define that resource adapter in line. It's natural to have a dependency on something that is already packaged within your own application. So you're okay in putting that in an annotation. So these are ease of use extensions that also enable cloud services. All right, let's talk about a few of the multi-tenancy models. There is the PaaS model where you want to deploy an application, and the moment you say to your PaaS provider, here's my application, you upload it, and you say, now deploy it. What does a PaaS provider do? Well, it may choose to do a couple of things. One thing it may choose to do is it may choose to create a whole virtual machine and spin up a software stack on that virtual machine and then deploy your application to that stack. So that's kind of a whole new runtime stack per tenant. If it's a more advanced PaaS, it might, or perhaps less advanced, depending on what your perspective is, the PaaS provider may have a single container and simply spin up an application that you've submitted for you and deploy it in that container. So you're divided from other tenants through application walls. All right? And that's another option. So that's what we call a PaaS multi-tenant container, where applications from different tenants are all running and co-resident. The third one is a SaaS approach, where you have an application and the tenants are coming in through that same application instance. That's the traditional multi-tenancy, where tenants are, in some cases, have resources, and you're going through this application. The application is responsible for multiplexing the tenant to different resources. Now, you see this star number 3, the SaaS limited. SaaS limited says, well, we've got a SaaS scenario. We've got a shared or an application that multiple tenants want to use. But the approach taken in the SaaS limited is the application for this tenant is deployed. And when this tenant wants to use that same application, you spin up another application instance for them. So even though the tenants are using the same application, the same code, there's a different instance running for different tenants. So they're isolated in that sense. So it's not what I would say, what we traditionally would say multi-tenant. So in Java EE, the support that we're offering in Java EE 7 is going to be separate isolated instances, okay, for the same app. So we would support that limited SaaS that we saw on the previous slide and the PaaS model up above. So that's the target for Java EE 7. An application gets deployed for each tenant, and the application would then be aware of that tenant in some way, and we'll discuss how that would happen later. The resources might be, again, tenant-specific or private to that particular tenant, or they might be shared and global to those tenants plus other tenants running in other containers or other systems. There might be entirely like global database, for example. It might be accessible to everyone. So you'd be able to configure those either way. The real SaaS that we talked about, the for that is that there currently is not the right level of support within Java SE to even isolate different tenant memories. JVMs are not sort of protected in a tenant-specific way. You need sort of tenant support built in the JVM to allow you to secure one tenant's memory from another tenant without them having to go over there and perhaps see some of the other tenant's data. So we need some of that intrinsic support in order to enable a true SaaS and have it done properly. So that's one reason why it's being deferred. I think another one is that we also want to see what happens in the market. We want to get more experience with it. Currently, there's not a lot going on that way. There's some proprietary SaaS systems like Salesforce I mentioned that are out there, but those are kind of built very proprietarily. They're not this general SaaS solution that people can deploy a SaaS application and offer it to end users. So we want to see how this happens and what the platforms actually do and how it's worth standardizing in that way. So we talked about tenants, and since we talked about multi-tenancy, let's make sure that we understand what a tenant is. A tenant is essentially a different user, and the user, again, might be different granularities, but basically a tenant is the thing that is isolated from other things. So it's a unit of isolation. We refer to that as a tenant. The container is responsible for making sure that a tenant is isolated from other tenants, and it would do that, as we mentioned earlier, through those various models, doing either separate virtual machines or a shared container, but isolating and building walls up between the applications. How are we doing for time? Good. And the restrictions that may be applied within a given container or a PaaS environment could depend upon the environment itself. For example, if I have a queuing service or a message service, then I would be allowed to send messages using JMS or something. But if I deploy an application and I use JMS APIs and I don't have a messaging service, then the PaaS platform might be looking at my application and say, wait a second, he's using these APIs that he doesn't even have a right to use. So it could blacklist certain APIs based on what your permissions are, based on what your service levels are, and various other parameters. That would be up to the container and the PaaS platform to decide. Now we talked about an application, how it knows the tenant that it is running within it. And the way that it would do that is in Java, we would define a tenant identifier. And that tenant identifier would be something like a resource that you could either look up in JNDI or would be injected into the application itself. And you could then use that tenant identifier when you talk to specific resource types, particularly those that are tenant aware. They would need to have the tenant identifier passed to them so that they know, or have some context that they would also be aware of that tenant, and then they could do the proper multiplexing of their own resource types to apply to the given tenant that is currently active. So talking about multi-tenancy and resources, here are some examples of some multi-tenant resources. And I'm going to talk about databases because that's the one that most people know and are concerned about. The first one is a separate database. So if you're given an application and the application has database requirements, it typically has to know whether it's talking to a database that is shared with other applications or whether it's a database that is devoted entirely to that application. So there's nothing in the first model, nothing is shared. It's assuming exclusive access to this database. It's non-shared. It's all private. And so this is great for isolation. No one else is getting to my data. No one else can see it. There's no way they're getting into my database. That's great. But for every application that gets deployed, that's a pretty big cost for the PaaS provider. They now have to spin up an entire database. If they're using something like Oracle, that's no small feat, right? That's going to take some resources. That's why you'll see when PaaS platforms out there today give you a whole database service, they're going to use a small database that perhaps doesn't give you the same quality of service or the same level of features. They're going to give you a Derby or a MySQL or something that's a little smaller, or they're going to choose the second option and give you a logical view of your own database. So it might be a shared database, but they'll just give you a schema in that database. Now the schema level is a little bit more practical in the sense that when somebody asks for a database service, the provisioning of that data service involves simply going to the database and spinning up a schema for that tenant, and then mapping that schema to all of the connection information that the tenant needs. So that's much better, less resource intensive. You're not spinning a whole database up. You're just creating a schema for it. And the isolation, it's a good trade-off. It's got pretty good isolation because you're separated by schemas, and most databases can separate and isolate schemas from each other. So that works out pretty well. The third item, though, or the third option here is sort of swinging to the other side, where it's very easy if you share the same database and the same schema across all the tenants, but there's this risk, and the risk is quite high when you have this shared table and you have all these applications and tenants' data sitting in the same table. Now, something like Oracle VPD or a virtual private database offers a feature like this where it will protect it for you. Okay, it has these permissions built in through this VPD service. There are other databases that have similar type features, but the isolation is I guess somewhat, it makes people nervous because you got shared tables and you got all these rows intermingled with different applications and different tenants. And in a JPA, which has to access this, and so JPA is close to my heart because I help out with the JPA spec and work on JPA a lot. To us, this means, well, there's a bit of work to do there potentially. If you have a shared database and separate schema, well, that's not so bad because you can go ahead and map to your tables and everything's okay. But if you had a shared schema, then that means that the provider has to use this tenant ID field or a column inside of the database tables to provide the isolation. And that also has consequences on how you can program. If you have a tenant ID in a column in your table, then you really shouldn't be allowing the application to do native queries because they could actually access some other application's data, some other tenant data in that same table just by including a different tenant ID in their native query. So in a JPA sense, you wouldn't allow native queries and things like that. So it's culture break time. This is to wake you up. Has nothing to do with Java EE. I'm from Canada, and in Canada we have raccoons. Do you guys have raccoons here? No, I didn't think so. Raccoons are a nasty little critter. They have masks on, and they're built in. They don't put them on, and these masks make them scarier. They sleep during the day and then come out at night, and so they forage for food. And when you're camping, as we do a lot in Canada, we camp and we bring our food in these coolers. And raccoons are very good with their hands. And they can open coolers up, they can open up combination locks, they can pick the combination lock. No, I'm just kidding, they can't do that. No, but they can do a lot of things, and so they're very clever. And the best thing I think they're like software developers, because they solve problems. And that's what we do as software developers, right? We solve problems. So raccoons, I was thinking if we could harness the power of raccoons, then we would solve all the world's problems in software. But so what you do is you'll see them around garbage. They'll come around garbage and open up garbage bins and undo. They're very good with their fingers, as I say. So they'll undo those kinds of things that you think they couldn't actually get into. So they're also a little bit aggressive sometimes. If you go to certain areas and they get used to people, then they'll fight you for the food. You got to be careful. They're not timid. Okay. Well, now that you're awake, I think you're ready for roles. So roles. As I mentioned earlier, roles are a little more complicated. They're a little more complicated in the cloud because you have, on the one hand, you have the cloud provider. So they're the ones that they have the product, right? They're the ones you go to when you want cloud access. But inside a cloud provider, if we're talking about Java EE as a PaaS stack, then the cloud provider may not have been the ones who actually developed that Java EE stack. They may have acquired that from somewhere else. Okay, so they may have purchased or have some agreement with some Java EE provider, and so they bring Java EE into their cloud, and the Java EE product provider makes sure that all their Java EE code is working properly and passes all the CTS and everything like that. And then the cloud provider then has a cloud account manager which deals with all the customers. So as a cloud customer, I want to use a cloud, I would talk to the cloud account manager, which may be online, just registering. That might be some cloud account manager on the other end. Or if I'm a big corporation and I want to use this cloud in a very big way, then I might need to actually have a meeting with the cloud account manager. So my own company has some account rep or whatever that we go to talk to the account rep at the cloud provider, and then they meet and they have dinner and all that, and before you know it, something's signed. And then I want to deploy an application on that cloud. So I need someone in my company to create that application. So that's all the same. There's an application developer and all that. But there might be some submitter that says, oh, here's my application. They're not really a deployer because they're not really deploying it yet. They're just providing it, uploading it into the cloud. So that's this extra step. And then I have this application administrator on the corporation side, which makes sure that my application is running in the cloud as we expect it to. So here they are listed, and I put the deployer in the middle because the deployer might belong to one side or the other depending on the situation. If you're talking about a PaaS situation, then the deployer is going to be on the vendor side, so the customer side rather. The customer is submitting the application, and it's going to be deploying it. If it's a SaaS, then it might be the SaaS provider, which is kind of sitting in the middle here. It's not really the end customer. It's this SaaS provider developer thing that is going to be actually doing the providing and the deploying. So a few use cases. The Java EE vendor, well, we call that the Java EE product provider. The cloud provider wants to support Java EE applications. So the cloud customer writes a web app, and then we'll deploy it to the cloud infrastructure, and end users will access it. But in the case where a software company writes an application, submits it to the cloud provider, and then the tenants then sign up to use that application. So this is like a SaaS case, right? This is a simple SaaS. So I have some software company there, and it says, I want to write a CRM software module, and I'm going to sell it and make lots of money. So I need somewhere to run it, and they go to a cloud, and the cloud then says, okay, we'll host your application, and now you just go off and get end users to go buy it from you, and then they'll use it. So there's these middlemen. So let's go through a scenario of this. So let's say that we have this cloud provider called Diablo Cloud. Diablo Cloud is a cloud provider that is offering cloud services. They have all these resources. They have Java EE in there. And now Simply CRM says, I want to develop a CRM application and then host it in the cloud. So they hire an application developer like you or you or you, and you go and write this application for them. You say, here you go, here's your app, and they take that and they sign up as a customer with Diablo Cloud, talking to the cloud account manager. They submit it, so we have some application submitter here, which may be the developer or maybe someone different. And Walmart says, I want to use that app. I want to use that CRM. So they find out about this CRM app, and Walmart says, that sounds like something I can use. I'll pay money for that. So as a cloud customer, they sign up as a customer to Diablo Cloud. And Diablo Cloud says, yes, we have that CRM app that way back there, these guys, Simply CRM, created. And so this deployer might be Walmart, or it might be Simply CRM that deploys it for them. They deploy an application instance for Walmart. It's configured for Walmart. It has their data and users at Walmart. So Walmart has a bunch of salespeople or whatever that now access their CRM software on the cloud, on Diablo Cloud. And notice that the people who wrote the application are nowhere to be found. They're just raking in the money, right? That's all they got to do. Because there's this relationship. It's kind of a tri-relationship where these three different parties are involved. And in the end, some administrator has to administer it. And it might be Walmart, or it might be even Simply CRM if they've been paid extra to do that. And then meanwhile, even at the cloud provider, they have to make sure that all the resources are running properly, their software is still up, yeah? And then it's monitoring to make sure that the serviceability and performance and all of the other SLAs are being met. Okay, so just to also give you a brief overview of some of the other things that we're doing in Java EE7. It's not always just about the cloud. We have a few other things that are going on. We're talking about managed beans in CDI and doing some I thought I saw that. Okay, good, thanks. So we're kind of doing some coordination across the specs, some amalgamation, and also some correlation through each of the various sub-specifications. There is some ease of use that is still going on in terms of we saw the services that we listed earlier with the annotations. That will still, you can use that anywhere, not just in the cloud. Some more dependency injection and stuff. Some of the things that have been, I would say, less used or less useful have been pruned. An example of that is the old EJB CMP. Nobody really uses that. JPA is a sort of a new way of persisting objects and a much nicer and more standard way of getting objects to a database. JSR RPC is no longer there, and the deployment API is not used. So what does pruning mean? Well, pruning just means that the technologies will be optional in future releases. And by optional, that means that a Java EE provider may implement them, or they may choose to not implement them. But if they do implement them, they still have to be compliant. So it's not like you're getting some half specification and it's optional, I can do some of it or leave the rest of it out. You still have to be fully compliant and pass all the TCK for that technology. But you may choose to not implement any of it as a vendor. And then the web profile will be updated to include things like JAX-RS, for example, and possibly JSON. So these are things that have become much more prevalent in our development experiences now, and so they make more sense to be added to the web profile. Number of JSRs on the go. We have some updates to existing JSRs, and we have some new ones. You see all the 1.0 here in the specifications are new. The concurrency utilities is a series of additions to what the Java SE concurrency offers. And we have the JCache, which has been going on for quite a long time, actually, a number of years, and has been restarted. And so we'll be offering an API as part of Java EE 7. I mentioned the JSON one already, and there's the state management and batch processing that are on the go, I believe, as well. And then there are a few just maintenance releases to existing specs. So there's a fair bit going on in Java EE 7. The big change in the process is that there is a new JSR within JCP that dictates how JSRs run. Okay, because the JCP is a self-governing process. And so whenever you want to change the JCP, you have to have another JSR. And so it's reflective. But the new JSR dictates that all new JSRs started should be open and transparent. So that means that all developers, anyone in the world, can go and sign up as a user and follow the expert group communications, the emails and things like that. You can watch and you can raise bugs against the spec. There's a JIRA for bug tracking. So you can, if there's something you think should be changed, you enter a bug. Or you can choose to send an email to the expert group directly. But you can certainly view everything that goes on there. There's a java.net project for every specification. So you can go and become a member of that java.net project and become a part of that specification in a sense. There's a wiki. You could see all of the Java EE reference implementations are typically in the open as well, so you can generally look at that and see how that's going in the Java.net projects as well. So I would encourage you folks to go to your favorite specification that you are interested in and like to follow and sign up to the project. The JSRs are pretty much all up and running now. There are a couple laggards that are still just waiting for some of the process work, but the release is scheduled for next year, and it's date driven. So if there's something that is being added or that is being substituted for, we decide that some other feature is more important than one that we're doing, then we will do that. And if something else gets left out and not done, then it will get left behind because we have to ship. So I would encourage you also to go to those Java.net. These are some of the URLs that you can use. You just can slot in the appropriate spec and use that URL for the signing up on the project. And of course, you can also just send it feedback to the user list directly through the user's email address